Okay, so here we're doing some more probability, and two types. Probability an event will not occur, and the probability of this or that occurring. Now, something about this section in the book is that we are doing things like picking one card, throwing the die one time, pick one person. So it's kind of important to say that because 11.7, it differs in that regard. And after we've done all 11.6 and 11.7, then students will come back and say, I'm really confused because between the two sections. Oh, that light is in my eyes on your phone. Yeah. The back for your line, the phone, the light was on. Thank you. All right, anyway, so in this section, we're doing things like pick one card. And so let me write that. In 11.6, we are looking at one thing happening. This would be like pick one card, roll the die one time, pick one person. And what I mean by the this or that is it could work like this. So we pick one card from a deck of 52. So there's your one event. And we want to find the probability that the one card is a 2 or a 3. So when I say this or that, that's what I'm talking about. And so what I would do is count the number of each, count the number of 2s, count the number of 3s, and figure it out from there. How many 2s are in the deck? There are 4 of them. And how many 3s? There are 4 of them. How many ways could that one card be a 2 or a 3? 8. 8 over 52 would be the probability, so that would reduce to 2 over 13. Now, there's another type of this or that problem. So it's something like this. So when I say kind of there's two subsets of the this or that, here's another example. Pick one card from a deck of 52. Find the probability that the one card is a red card or a 9. Now, this is a this or that. It's a little different from the other one because, I hope you're thinking about this, I have 26 red cards. I have 4 9s, but, wait a minute. Here's a 9 and it's red. So this one, there's some overlap between the categories. There's another 9 that's red. I gotta be careful not to count those twice. So I have all the red cards, and what else do I need? How many more 9s are there? 2, the 2 black 9s. So I have to be careful. There's some overlap. There's 2 cards that fit both categories. On the previous problem, when I said a 2 or a 3, there's no overlap. So on this one, I have to take into account that overlap. And I'd like to just go with the red card first. Red cards, 26 of these. And then for the 9s, like wait, don't count the red 9s. We already have them. So there were 2 black 9s. So there would be 28 successes. Probabilities 28 over 52. That will reduce to 7 over 13.